Now that we know about how these gases work, we can go back to our respiratory system and see why they matter. So last week we started respiration. We talked about ventilation, moving air in and out of the lungs. And we talked that's actually it. We're going to do external respiration now. Gas transport is later this week. And internal respiration is going to follow the same principles as external respiration. Remember, cellular respiration occurs inside the cells and will come up briefly this week as being an important driver for why that carbon dioxide keeps being produced and oxygen keeps being used. So overview, we've done this, although we're going to come back to the regulation of it. So let's look at what's happening here. And actually, we started this last week, right? Already, you know that there is an alveoli, and it's made up of simple squamous epithelium. You can probably draw a better picture than me. I'm drawing cells, and then adjacent to those cells is a capillary. The capillary is made out of what? Simple squamous epithelium. So this right here is one side of our capillary. I maybe did it a little thick there. The cells are the same size as my alveolar cells. This is the other wall. Simple squamous epithelium. And now I've kind of run out of being able to use red here. Blood flow through here, blood. This is ventilation occurring right here. And the other thing that needs to happen, just a different color here, we've got to get oxygen in. It's going to diffuse across this respiratory membrane. Carbon dioxide is going to diffuse this way. We're going to see how that relies on partial pressure gradients. There's also a basement membrane. If we're going to be thorough and draw our anatomy here, there's just some basement membrane, which is mostly glycoproteins, kind of extracellular stuff, interstitial space through there. These thin cells, so diffusion is occurring across a thin membrane with high surface area. And those are important in addition to the partial pressure gradients. Okay, mostly review there. Let's look at the first step of this process. I want to look at partial pressure gradients, and right here, this is going to be atmosphere. Well, actually, I want to versus alveoli. In the battle, there's no battle. So first of all, we're going to draw some graphs. Let's up here do atmosphere. You know the partial pressure gradients. Actually, I'm not going to do that. Of carbon dioxide and oxygen in the atmosphere. I said oxygen, you should probably memorize this one, 160 millimeters of mercury. I'm not going to write it there because I can't fit it. PCO2, this is the one I said wrong once recently. It's 0.3. It's very low. We could graph this to give us, if you like visuals, this is very high. And PCO2 in our atmosphere relative to that, very low. How do you think this compares to alveolar air? Well, it's going to be similar, right? We're going to have higher oxygen than carbon dioxide, but it's not going to be equal. And this is several reasons. First of all, we've got the unloading of CO2 into this local space right here. So CO2 will be higher. Actual gas exchange is happening here. So that makes it not the same as it was in the atmosphere. It's also due to humidification in the conducting passages, changes the composition of the air as ventilation occurs. And then even as you're inspiring, old and new air is constantly mixing. So atmospheric partial pressures are not going to be identical to alveolar. Here's alveolar. This is air composition we're talking about, right? So slightly lower PO2, about 100, and slightly, well, actually significantly higher PCO2. This is largely due to the unloading of carbon dioxide produced by your body. Our bodies produce a bunch of carbon dioxide and we're going to exhale that into the air. We don't quite get all again, those things I said before, humidification, mixing of old and new air. We're not going to 100% be breathing in, have the same composition as we do in the atmosphere. So if we're going to graph this, we would see these slightly lower, right? This one is lower than before, and our carbon dioxide is closer to half, a little bit less than half of that. All right, so that's our first step. I am going to draw out the rest of these as we go, but this first video is just this part.